Hello and welcome back. So in the last video we talked about indefinite integrals of vector valued functions. What about definite integrals? So again, it works much in the same way as derivatives or indefinite integrals. These are evaluated component-wise. So if I want to take a definite integral from t equals a to t equals b of some vector valued function r of t, well, if I have just any antiderivative, so um, let's say f is an antiderivative for little f is antiderivative for f, right? G for G and H for H. So if I have these, actually I don't even think I need that notation for this video. That's okay. So I'm going to do this. Take a definite integral of this. I can also use, my ijk. So this is definite integral f of ti plus g of t j. Yeah, I'll do it like this. Plus h of t k dt. I can distribute this definite integral through. So this is the definite integral of f of t dt. And that'll be in the I direction plus the definite integral from a to b of g of t dt, and that'll be in the j direction, plus integral a to b, h of t dt in the k direction. So once again, the definite integral of a vector valued function, in order to do that, we just need to find definite integrals of each of the components and then combine them. So not too difficult, so long as we know how to do definite integrals. So here's an example of this. I'm going to take definite integrals of each one of the components and then combine them. So this is, I'll do definite integral from 0 to pi of, well, just 1 dt, and that's in the I direction, plus integral, again, 0 to pi of 3 cosine t over 2 dt, and that's going to be in the j direction, minus integral 0 to pi 4t dt, and that's going to be in the k direction. So now I'll evaluate each one of those. So this is just t from 0 to pi. So I'll say t evaluated from 0 to pi in the I direction. Over here, I'll need a u substitution, right? Or just kind of think through it. Let u equal t over 2. Yeah, maybe I'll write that out. U equal t over 2. Then du dt is 1/2. So I can say du is 1/2 dt, or 2 du equals dt. I can make a substitution there. So I'll get what? 6 cosine of u du. So that'll go to sine. And so what I should have here is 6 cosine of t over 2, evaluated from 0 to pi. I'm hoping you're good with your integration and can do these u substitutions. It's okay if you're not. I don't mean to shame you, but rather if you're having trouble with these, you need to go back to when we first talked about definite integrals and practice some problems there. And come see me if you need help. I'm always available to help. 6 cosine, no, that shouldn't be cosine, right? Did you spot the error? That should be sine. And I can always check my answer for these definite integrals, or for these indefinite integrals rather. So this would be cosine of t over 2 times the derivative of the inside. I'd get 3 cosine t over 2. Yep, that checks out. Lastly, here I have 4t, so that's going to go to t squared divided by 2, so that's going to be minus 2t squared, evaluated from 0 to pi, and that's in the k direction. So let's actually do this now. So that's going to be pi minus 0 here, so that's pi in the I direction, plus, let's see, sine of pi over 2 is 1, sine of 0 is 0, so that's just going to be 6, and that's in the j direction. And finally, with k here, that's 2 pi squared minus 0, so this is just minus 2 pi squared in the k direction. And if I want, I can combine this into component form. That's pi 6 minus 2 pi squared, and this is the definite integral of my original vector valued function. So notice I get out a vector, And more importantly, I get out a constant vector because I've now sort of, remember thinking about finding areas under curves. We're going to want a geometric interpretation for these things. We're not quite there yet, but at least we can evaluate the definite integrals like this. Okay, that's it for this video.